Well, Monday is here again, and here I am again in my bright yellow t-shirt. Usually I try to wear a dark shirt because it doesn't reflect on the screen quite so bad, but I got a few random little items I want to show you right now. To begin with, this is a Delorean engine. This engine was somewhat familiar to me in its basic design, because it's like the engines that Eagle Premier had them. That's like, basically that's an Americanized R25 Renault, as I remember. But one way or another, this particular Delorean engine had K-Jetronic fuel injection on it, which had those little atomizer nozzles and a fuel distributor and all that kind of thing. And that was a system that was a Bosch design, and it worked pretty good, really. It wasn't like any other fuel injection system you're ever going to see, you know, because it was a totally mechanical fuel injection system that there was nothing really electronic about it until later, when they had to put frequency valves on there to to give it the ability to control the mixture based on oxygen sensor input. That particular kind of fuel system was used on Volkswagen gas burning Rabbits and stuff like that too, although some of those had carburetors on. But you can see that exploded view on that, and all the way up until as long as the Eagle Premier was a thing, this is pretty much the engine it had. Now this was a 2.8 as I remember, and that Eagle Premier had electronic fuel injection. It was a 3-liter. It had electronic fuel injection, and it had electronic ignition on it, rather than having fuel injection electronic ignition. It was different from what the DeLorean had on it. But the basic engine design is a pretty good one, actually, and it was fairly much ahead of its time. This is a distributor cap. Now, the reason the distributor cap had you notice they got these two towers, and they got those two towers, and they got those two towers. They got them separated like that. The reason they had to do that was when you make a 6-cylinder engine, with the, you got the 60-degree V and the 30-degree V and all that, but the 45-degree V or whatever it is. Anyway, I don't remember all those angles, but the point is, you got a Y block, like the 3-liter Taurus and all, and then you got the block that's the wider ones, like your Chevy engines and this one here. If you don't splay those rod journals on that crankshaft, if you have them like this, like you have on a V8, this works okay on a V8 with evenly spaced towers on the distributor cap. But when you've got a V6 like this one was made, and it has these in the same, which is really, this is stronger than that, because if that crankshaft breaks, it's going to break at that place right there. It's a little football-shaped piece of metal holding it together. This one right here causes you to have these spaced this way, and that's the reason that DeLorean always has them funky distributor cap spacing like that on there, was because it was made like this instead of like that. And that was something that, gearhead engine design people will talk about that quite a bit, and they probably get into it a lot deeper than I can. This right here was something that this particular vehicle had been at a shop here in town that's really a pretty good shop, and I was kind of surprised that they told her that she needed an engine or something. With major repairs, because she had water in the oil. But it turned out all she really needed, this is a 3.1 in a Pontiac, as I remember. This gasket was blown. This intake gasket likes to blow, and oil likes to go into there. Now, some of these Ford Flex vehicles have got a water pump that's driven by the timing chain inside the engine there, and when that thing starts to leak, it fills the engine up with coolant. The 2.7 liter in the Chrysler Sebrings and stuff like that, they had a water pump that was driven by the timing chain, but whenever the water pump seals failed, they had two different places that coolant could go so that it didn't go into the oil pan. Now, one of the coolant weep holes on those, it was down there by the thermostat on the front side of the block, behind the AC compressor. And the other one, if that one was clogged up, there was another one that would go into that valley underneath the intake, and it would run down over the back of the transmission and all that kind of thing. But anyway, this is a water in the oil situation that happened because of this. Now, typically, whichever has the most pressure In other words, if you've got two chambers, one of them's carrying oil and one of them's carrying coolant or something like that, the one with the most pressure is the one that's going to be pushing whatever it is in the other direction. That's like when you've got a blown head gasket, you can push compression into the water, but sometimes if the way the gasket blows, and this has always been sort of mysterious to me, the water will weep into the combustion chamber after a hot soak when you shut it off, but there's not any compression getting into the water. You see what I'm saying? So that's just you know, a lot of times people will say blown head gasket without really checking anything. But there's a whole bunch of different ways head gaskets will blow. I've covered that on here before. But this is kind of what it looks like here on one of the Ford diesels when you get oil in the water. Now, part of the reason that that happens, anytime you've got a chamber like you might remember the Saturn I was talking about that had oil in the water. If you got higher oil pressure than you do coolant pressure, and so where the most of the pressure is where the fluid's going to change. So if you got higher pressure in the oil than you do in the coolant, the oil's going to go into the coolant. If you got higher pressure in the coolant than you do in the, and not the pressurized oil area, but the place like underneath the intake where that pressure can just go in there. There's not any crankcase pressure in there. So wherever your highest pressure is going to be the origin point for whatever's contaminating the other fluid or the other area. Now this right here, this is interesting here. You see this tire tool that went into that tire? My son worked at a tire store, and every now and then I'd get a picture from him like that. That was back in 04 until 04 when he went into the Navy. But this one here wasn't covered by warranty. This is a road hazard thing right here. He ran over a tire tool that was in there, and this one here busted the doggone rim. It ran over something hard enough that went through the tire and shattered the rim. I don't know what it was. Paul Harvey talked about one time on his program about a guy that ran over one of these long bumper jacks that was laying in the road, and his tire flipped it up in such a way to where it came through the floorboard like a spear coming up through the floorboard, and it killed him. You never would expect to hit something on the road that could come up into the car like that and go through the lower part of your body and kill him. That's what happened to that guy right there. And if you think about the way those jacks were made, that's back when they had the old bumper jacks. They put on a bumper and raise it up. All right, this right here is something you had to deal with on those integrated caliper park brakes, where you have to actually, this is a little bit annoying because the threads in here are a different pitch than the threads out here. So whenever you're trying to screw this thing in there, you got to actually work this and that to keep that engaged with this, so you can screw that back in so you can put your pads on. This was something that we used to have to do all the time, and a lot of vehicles still have this. The ones that I really like the best are the ones that have the park brake in the hat, in the rotor hat back there in the back. That makes more sense than any of this kind of hogwash, but you're liable to see this on first one vehicle and then another. Like, for example, this is the way it was set up on Ford 500s, but on Crown Victorias and stuff, they would have the hat. So I don't know why they decided. Some of the Tauruses were set up this way too, if they had disc brakes on the rear. But a lot of Tauruses had drum brakes on the rear. My sister-in-law had a Taurus that she had needed rear brakes on it, and she came for a visit. She came to visit my wife, who was her sister, and she said that up in the town where she lives, it's a college town way up in the northern part of the state, she had a couple of places give her estimates of $300 to do the rear brakes. And so I said, well, I can do the rear brakes in the driveway. And so I went and bought a set of brake shoes for $16 and jacked the car up. My wife and her sister were in here checking, talking to one another and fellowshipping and all. And took me about 30 minutes, and I put a set of rear brake shoes on it and adjusted them up so the pedal was good and snug and all that. And so 30 minutes, $16 worth of brake shoes. She was my sister-in-law anyway. I charged her $20. Now, with all due respect, I know shops have got a lot of overhead, and mechanics got to be paid and all that kind of stuff. But some of the prices they charge for doing brakes is just totally astonishing. I think over here at the Ford place, you can get lifetime brake pads put on for $129. If you'll pay them $129 to do your brakes, as long as you drive that vehicle, they will do your brakes for free from then on, which is a pretty darn good deal when you think about it. If they can afford to do that at the dealership, they can afford to do it at some of these independent shops. what will happen to these rides? I saw this this car, and this somebody parked those under there. I don't know if they still drive that one or not, because the tires aren't flat like they are on this old. That looks like about a 51 GMC or something. But this thing right here, I don't know what kind of vehicle that is. But the tires aren't flat. Got those moon hubcaps on it. This one ain't got no hubcaps. But this is dusty, like it's been sitting there a long time. And I always wonder about stuff like that. They parked those. My uncle had a 53 Ford or 52 Ford that was parked under a shed behind his house for a long time. It was black with a red interior. And it just sat there and sat there and sat there and sat there until it finally went bad. I mean, all the brakes were locked up, everything. This, you know, I mentioned earlier, this lady had a 73 Volkswagen Bug that she found in the barn out there in the, you know, house where she grew up. And it had been sitting there ever since she graduated from high school 40 years ago. And she was all excited about getting that thing running again. I think she thought she was just going to pour some gas in it and jump it off and drive it away. But I told her, I said, everything on that car is going to be seized up probably, even though it's been sitting in the barn. And it's really interesting how sometimes things seize up and sometimes they don't. Sometimes a car that's been sitting up a long time will actually still fire up and run really good. And that is, you can't ever count on that being one way rather than the other. But here, typically, fuel-injected vehicles are worse when they sit up because the gas pump goes bad. You know, the fuel pump goes bad, the gas goes bad, wipes out the pump, clogs up the fuel system. It's a big mess. Now, this right here was a funny little thing where the customer was working blind at night, reaching under there, just feeling his way around. And he said he still had a coolant leak after he got done. And when we looked under there, it's a wonder this didn't blow off and burn the motor up. But that he had clamped, he'd run the clamp down really tight around the neck where the radiator hose went on. And that was sort of interesting and funny. But every now and then you see that. You know, have you ever been in a situation where you couldn't really see what you were doing? You're just working in the dark and all that. And if you don't know what to feel for under there and how everything's going, this kind of thing's a fairly easy mistake to make, you know. Now, these things right here are extremely annoying. This Teflon ring on these Ford Teflon power steering lines, it goes right here. You're supposed to work that thing over, and it's real stiff and hard too. You're supposed to work it over those threads and get it right in there. Okay, and basically whenever you unscrew that power steering line from that power steering pump, most of the time it ruins these. Now you can get them from the parts store in various different sizes. They got little packs of them that's got them Teflon seals. But those things right there have always been annoying to me. And you know, routinely, and a lot of times people will screw the power steering line out of there thinking they're just going to screw it out and screw it right back on. But when you screw it out, it mangles this doggone Teflon seal, and you wind up with a mess because you got to get another one from somewhere. And if you can't find one, you know, there's little parts sometimes that you have to have that can put the car down for the count. When the customer brings it in expecting to get it back that same day, or maybe when they were at college, they worked at the same place I did, and they needed that car to drive home, and you're doing a job that ordinarily won't down the car. But one time doing brakes, I had one student that was being overly zealous, torquing the brake line, you know, the banjo bolt, putting the brake line back to the caliper and busted the banjo bolt, and of course nobody in town had one. Well, you can't release a car like that obviously because you got no brakes. And so we had to order that banjo bolt, and I think it took 2 days to get it, you know. And that customer wasn't happy about that, but people make mistakes, you know. Now I like to look whenever I want to see the source of the noise. If you look at a bearing that's brindled like that and you changed it out, if I can look at that bearing and tell it was brindled, I like that. Now, I have taken bearings and popped them apart or cut them apart and looked at them that I got off of vehicles before. And on one of them there was a really noisy front hub bearing, and I replaced both hub bearings. A lot of the times it's best to replace both of them because sometimes whenever you're doing the swerving back and forth thing, you know, you'll get thrown off course thinking you're replacing the one on the left that's making the noise, and it turns out it was the one on the right. I got a guy that owns a tire store down here, and he's been in this tire store business doing bearings and stuff like that for 50 years, and he says that he gets smacked around sometimes trying to figure out which bearing it was. But anyway, a lot of times if you just put them both on there, you know, sometimes that doubles up on the cost of it, especially if you're buying the darn things at the parts store where they won't you know, between $250 and $400 for each bearing. It's kind of spooky too, you know, whenever you're wanting to do that. So that's why I bought mine, you know, from Detroit Axle, the ones I bought, put on mine a while back. I made a video on that. But I don't see any point in paying $250 to $400 for a bearing that I'm going to put on myself if I can order one from Amazon from Detroit Axle. You know, they can, a lot of the markup on some of this part stuff is pretty high. And I understand they got overhead and all that kind of stuff, but I mean, there's the money between $80 and $250, which is the cheapest one I had was $250, and it was DriveWorks, which I don't trust anything DriveWorks hardly. But and that's another story. Golly, I think I told you all that the other day. The guy swore up and down that him and his boss had cut a DriveWorks part apart, and they said the DriveWorks part was 10 times as good as the OEM. And I said, really? Are you serious right now? You know, I'd seen too many of those DriveWorks parts fail. Not all of them, but some of them, like there was an idler arm on a Chevy pickup, and it would last 2 weeks, and they got another one, and it would start flopping around loose. Got another one. It looks just like a Moog, but when you put it on there, man, that thing just won't last. Usually, though, bearings are okay if you get them in DriveWorks or something like that. And I've actually had a situation where I got a coil that was a DriveWorks that did better than the Intermotor brand. So it's a sort of a fruit basket turnover. Anyway, I sort of got sidetracked on that thing. I hope I didn't get too far. Environmental responsibilities are important. I used to take my the oil filters and just throw them in the trash. Well, this guy with a hard hat and a clipboard came around one day from the state, and he says, you're not supposed to do that unless you poke a hole in that filter and let it sit there 24 hours, and then you can throw it in the trash, because the oil can gurgle out of it that way, I guess. That still seems like you're throwing oil away. But I got from Safety Clean this barrel, and we would throw all of our transmission and engine oil filters in there. When it was full, they would charge a fee, and they'd haul it away and put me another empty barrel there. I also paid $160 for this, and that was for my waste oil that I would pump in there. My coolant, I actually kept in another one of these that was outside the shop, and whenever I would, what's amazing is if you take one of these drain pans that's got that snout on it and stand it up over a jug, whether it's oil, whether it's coolant or whatever, if you leave it there all night, that drain pan will just about be really clean, so it ain't hardly anything left in it. Anyway, whenever I filled one of these up with antifreeze, I would take it outside to the other one like this that was coolant, and I would fill that up, and then periodically they'd come pump that out. Now, if you've got some of those yellow and gray bottles that you've got contaminated refrigerant in, you're going to be stuck with those, because you might know somebody that will come pick those up. But I asked Safety Clean one time, would you come and pick up this, you know, this 50 pound or 40 pound or 30 pound, whatever it was, container of used refrigerant? And he says, yeah, but it'll be $2,000. And I said, well, I think I'll just store it for a while. I don't know what happened to that eventually, but anyway, environmental concerns are always something that I like to push on here, and I taught my students that too. Used oil in here, and oil filters in there, and try to keep that stuff out of the groundwater and all that stuff. Now this right here was a fan wiring training aid I built, and I put the blower resistor in there, and I put the fan switch right here, and I put the motor right here. And I use these. This is an idea that I got. Ford Motor Company would teach this way with little training boards that they built with plexiglass at the Ford Training Center. I thought it was cool as all get out. And so when I started teaching in 2001, I started building these little training aids, and it's cheaper to build these than it is to buy them. You know, if you buy one, you're going to pay, you know, anywhere from $3,000 to $5,000 or $8,000, $10,000, $30,000, depending on what you're doing. But I'd get old parts, and I would build these things right here, and I would make these guys. I'd have a schematic of the switch, of the blower resistor, and I would make them wire this thing up so that whenever they operated that switch, you know, and it was, you notice it's sitting on this so that the air can come and go out each end. And that was something that I got from another department. They were throwing it away because it was already plexiglass that was already built. It worked really good to use a jumper box to wire that up. That's the brake trainer right there, where I'd have them take the brake shoes off and put them back on. They love doing that. Whenever I got those guys used to doing that, they got to where they really liked doing those rear shoes. This is the fuel injection trainer board, and it had little LEDs on all of the injectors so you could see how they were firing and all that. Little fan pulling air through the mass airflow sensor, and you got this coil right here. One day this thing was spinning, and I was talking while that thing was just continually firing, and I was standing there next to it talking, and I got kind of lightheaded because I was breathing all that ozone. I had to turn the darn thing off. Ozone ozone happens every time a spark happens. But all of these were Mark II, and they had to wire this up. There's the engine controller, and I had the idle air control, and I had the throttle position sensor, and all this stuff labeled. And I even had the scan tool port right here, where when you wire that up, you could plug the scan tool in, and you could read everything. This is a '98 Explorer setup, the engine controller and all of that. That one over there is the ignition system board that's behind him, you know. And that was an engine I had over there on the stand that we could fire on. That was an old 350. Believe it or not, you can do all kinds of training on an old 350. And I'm not even going to get into that, but I mean, sometimes I used to have them, you know, pull it down and put bearings and rings in it and all that kind of stuff, so they could learn how to just basically do that. My shop foreman told me when he was in the Air Force and he was learning wheel vehicle mechanics and learning engines and all, they gave every one of the cadets that was training a lawnmower engine, a Briggs and Stratton, and they had them tear it down, put it back together, because you had everything you needed right there. You had your rings, you had your bearings, you had your timing marks on the gears, and all that kind of stuff. This right here was a measuring exercise they used to have these guys do with this thing right here, and I would have them measure it in 8 different places and write down the readings, and then I would look at it, and then I would go along behind them and measure and make sure they did it right. And I had a whole pile of rotors. You know, if you do a lot of brake work and you save them, you're going to have a bunch of rotors laying around. And also, if you got a bunch of rotors laying around, you can actually teach them to machine the rotors too, and that worked really well. This was a landmine job. I had to pull the head off this. The way it started was we were doing valve stem seals on this. Everything was fine, went all back together just good. We'd done those before, but it was all back together, looked like. And I went over and looked it over, and the guy that had put it back together was a pretty good mechanic, but he had forgot one crucial step. He forgot to torque the cam gear bolt adequately. Now this was something that would have probably happened no matter who started it up, because I mean and it was something that was easy to forget because he had a lot of steps he was going through, and he was a learner. And so when we started this darn thing up, it actually spun out of time because the cam gear bolt wasn't tight and it bent some valves. And so I had to pull the head off, we had to replace the bent valves and all that. But the problem was that hole right back there, and I've talked about this a little bit before, there was fluid or something got down in that hole, maybe a little bit of antifreeze. Not a lot of it, but when the guy that put the head back on torqued the head, it started to shear those threads just a little bit, because it hit the liquid in the bottom of the hole before the washer under the head of the bolt made contact with the head. And so he thought he had torqued it. He actually torqued it to spec. But whenever there's fluid in any of them head bolt holes, you're not going to get a torque on that son of a gun. So you got to blow all those holes out. And it's not a bad idea to go ahead and clean the threads up too. But anyway, the point is, this engine ran good after we got it back together, but before very much longer, those threads in there that he had started to shear and didn't know it gave way, and it started leaking oil back here. And so we wound up having to pull the head back off and then repair those threads with a helicoil. And it was just an absolute mess. I think it was like a year after we did the work. And I told about this on one of my other YouTube videos that I had. And this one guy just kept sending me message after message after message. This drove him nuts. Then I went ahead and we went back in there and fixed this thing when technically it was out of warranty. But I knew it was something we had done. And besides that, we were at the college, and and I knew the guy that owned the car too. Anyway, we eventually got that straightened out. But that was, some issues on that car for sure. Now this is a student that I had tearing an engine down, just so he could get a feel for all of that. This is an old push rod engine that I had over there. And I could notice that I was impressed with how organized this guy was when he tore that thing down. He had his rod caps, his main caps all in order, and he had the rod cap was put on the rod like it was supposed to be. You can't swap those from one rod to the other, and you can't swap those from one position to the other. These better be numbered. It's a good idea to number these so you'll make sure you're putting them back like they're supposed to go. I learned that one of the very first things I learned building engines and all that, but laying it all out like that. Even, believe it or not, on some of the older Fords, There was, when they didn't have adjustable, like old Chevys, you use that self-locking nut to adjust the valves. On some of the old Fords, you were basically supposed to measure the length of the push rod and get those exactly right. Although most of the time it didn't matter, you could just kind of throw it together. But really, when you rebuild an engine, you're supposed to replace those push rods if they're hollow, because you're not going to be able to clean them out good enough to get all the crud out of them. Push rods cost about $2.50 a piece. Ain't a big deal. Just go ahead and buy you some. Now, on that 3.1 that I was showing you earlier that blew the gasket and got coolant in the oil, that 3.1 has got push rods on it. They're two different lengths, and you got to pay doggone close attention to what you're doing when you put that one back together, or you can make a mess out of that. Just make sure you keep those push rods in order. One guy that I had in here, he got a piece of cardboard and poked holes in it and wrote down which push rod went where. A lot of mechanics just grab a handful of push rods and just throw them in there any kind of way, and that's, if that works for you, okay. It's always a good idea too to take the oil pump apart and make sure that it doesn't have a lot of wear in it that you didn't otherwise catch. One time I did a job on a gas burning 1.5-ton truck, and I knew the bearings and everything were in good shape, but it still had low oil pressure. And the oil pump, when I took it apart, I didn't see anything wrong with the oil pump, except for the fact that the relief valve spring didn't seem to have enough tension, and it was because it had low oil pressure, because you're not going to have any oil pressure with your relief valve not working right either. And I put about 3 or 4 washers underneath that retainer for that relief valve spring and raised the oil pressure on that one, and it was fine. That's not anything you usually can do. Most of the time, if you got an oil pressure problem, it's because there's oil pressure leaking from somewhere. And if you pressurize the oil gallery either through the oil sending unit or something, you'll hear where that oil pressure is going if there's a big oil pressure leak. Now, whenever you're turning, if you're turning one and you hear popping or squeaking noises or something like that while you're turning all the way, first off, if you hear popping noises when you're turning up under there, the first place I like to look is the sway bar links. Those are sometimes when they wear out, you'll get popping noises. But if you'll put a little grease right here, see where that steering stop is, when you turn it all the way, you can see how that one's been going up and down. Smear some grease on that every time you're under there doing any work, and you'll wind up keeping yourself. But these sway bar links, if they get loose and these rubbers are gone, you'll hear popping noises too. So inspect those while you're under there. But you need to smear a little grease right there so that whenever you're turning, if you're going over bumps, you can see how this would go and a squeak up, and customers don't like that kind of thing. So always remove the flywheel and have a look behind it. I always tell my guys, pull the flywheel off. We need to see if the rear main seal is starting to seep a little bit while we got the transmission out. So this one here, we had the engine out of it anyway. But I says, this right here is a good time to replace both of these expansion plugs while you're back here and replace the rear main seal. That one right there has been leaking for quite some time, see. And furthermore, I like to, when I pull these out, if I'm replacing all the expansion plugs on an engine job, I like to go ahead and get all the rust out of that that I possibly can. You can blow it out of there, wash it out of there with water out there on your steam cleaner if you've got the motor out of it. But if you've got the transmission out, pull the flywheel, have a look at this. You'll be surprised how many times you'll find if what's really a crime is when you put it back together and the darn thing winds up with developing a leak right here coming out of one of these freeze plugs that you could have replaced the expansion plug. It's not really a freeze plug, although it will push out of there when it freezes sometimes. But replacing those expansion plugs while you got the motor out on a high mileage engine is always a good idea, especially the ones that are super hard to get to. Now this is something I used to get irritated at when they don't put the tools away. You walk over here and the school day's over with and everybody's gone. They're supposed to have been cleaned up the shop, and they got all kinds of stuff laying out here. That's a cheap ratchet right there. But you get where I'm going with that. It's not ever a good idea to leave the bench like that all night. Whenever I had a bunch of different people working out of the same toolbox, it was always a disaster. Every time I've ever been in a situation where there's more than 1 or 2 people, or even if there's 2 people working out of the same toolbox, you're going to have a mess, basically. But and that was no, they left their safety glasses laying there. This is a funny thing. It's like a word problem. It says PO 841 low and reverse clutch pressure switch circuit. Okay, that's fine. But this is related to that same thing. Solenoid switch valve in left rear position. Really? what they saw was LR, which is supposed to mean low in reverse, and whoever typed this when they were programming that tool put left rear when they should have put low in reverse. Occasionally you'll stumble into something like that on an aftermarket scan tool. I thought that was kind of comical when I ran into that. That was on an OTC Genesis back in the day. You know what this is for? This hose within a hose, and they don't always look like that. Whenever the tank fills up to the point of where it stops that hose up, it clicks off, because you're supposed to have airspace inside the tank, right? So that actually causes the gas filler nozzle to click off whenever the gas is at the level it's supposed to be. All right? Now, I don't have any idea what happened to this Gates jacket, but I really did like it. Incidentally, I've also can't figure out what happened to that hat. I had that hat for a while here, but I don't know where it is now. But anyhow, that jacket was a really, really nice jacket. I will tell you this, though, it probably wouldn't fit me now because I was a lot slimmer and trimmer there than I am now. But that was a heck of a nice jacket. I kind of like to wear that. This is AC versus DC voltage. I actually created these patterns with an old Cal scope that we had over there when I first went there. And whenever I had a little transformer like you could buy at Radio Shack, and it's also like you might see in a little boombox radio or something. If you go in there, there's a little transformer in there. It's got 120 volts comes in one side of it, and it'll have 3 terminals coming out the other side, and one of them will be ground, the 3 terminals coming out the other side, and the other 2, one will be 6 volts and it'll be 12 volts. But I connected the scope, and I would plug it into the wall, and this would be 12 volts coming out, alternating current. Then I would hook a rectifier bridge up, and you notice the one that's down here would wind up here. And so that's DC voltage. That was both patterns the way I showed them. Now the cool thing about this is, if I didn't want these ripples, I can take a fairly large capacitor, electrolytic capacitor, which I got a positive and negative post on, you know, and I could hook that in series with this output, and it would flatten that just perfectly with a capacitor in there. I discovered that by accident, but kind of makes sense that it would. All right, now this right here is a little demonstration I made using a program I've got. And this is your alternating current, 120 volt AC. I used a needle, you know, for effect. All right, and notice right over here, this is 12 volt AC. You notice that one's pegging out. This one's supposed to be 12 volt, but it's stopping around 8. And this one right here, the rectifier actually is making it, it makes it bounce. That's kind of what you're getting right here. See what I'm saying? All right, and so let me see if I can make that play again. All right, now watch what happens. You notice how it's going back and forth. That's alternating current, and that's 120 volts. That's 12 volts, all the same meter. And this one right here, you're basically seeing this over here. And that rectifier bridge is vaguely similar to what you got. You used to be able to buy those little rectifier bridges at Radio Shack, but that right there is kind of like what you got in your alternator. Think about this as your alternator, and it's basically putting out through the rectifier bridge, and that's giving you your voltage. But you're going to see a little ripple coming out of the alternator, vaguely similar to that too. So anyway, I thought that was a pretty good little deal there. Well, that finishes our presentation for today, and I really appreciate you guys listening, and I hope you'll come back next time.